All right, let's dive right into something that's going to mess with your head a little bit. It's called the intuition paradox, and it really gets to the very heart of how we think we know, well, anything.
You've heard this a million times, right? This mind-bending idea from physics or philosophy that everything you see, everything you touch, it's all just an illusion. That our senses are basically lying to us, just giving us this nice, neat little user interface for a reality that's way, way weirder underneath. But, hold on. What if we've got that completely backward? What if the problem isn't our senses? What if the problem is with the logic we're using, the very abstract theories that tell us our senses are broken in the first place? Now that's the twist we're digging into today.
So first, let's get on the same page about what our intuitive reality even means. And no, we're not talking about just a gut feeling or some vague hunch. Think of it more like the operating system for your brain. It is the absolute baseline, the foundational code that everything else, all our logic, all our math, has to run on.
I mean, before you can build any complex theory about the universe, you have to first, well, observe the universe, right? That first look, that raw data your brain takes in before you even start analyzing it, that's pure intuition. It's the non-negotiable starting line. You can't start a race halfway down the track, and you can't build a theory without this prima facie, at first sight, data set.
So what is this mental operating system made of? Well, it basically boils down to three core components. These are the unshakable pillars that support every single higher-level thought we have.
And here they are: space and time, small numbers, and continuity. Now, I know what you're thinking. Duh, that's obvious. And you're right, that's the whole point. They're so fundamental that we take them for granted. But as you're about to see, this is exactly where the paradox kicks in.
Let's take that first pillar, space and time. This is essentially the grid paper of your mind, right? It's the where and the when for everything that happens. But here's the massive risk. If some theory comes along and says, hey, guess what? Space and time aren't real, then you've got a huge problem. Because think about it, every single scientific experiment ever depends on measuring something in a specific place at a specific time. If you declare that stage an illusion, all of your empirical data just evaporates.
Now for pillar number 2, small numbers. This is that deep gut-level knowledge that this is one thing and that is two things. It seems incredibly simple, but it is literally the axiomatic DNA for all of mathematics. The entire gigantic complex structure of math is built on that simple, intuitive idea. So if you're going to claim our intuition is fundamentally unreliable, you can't just pick and choose. You can't say our intuition about space is wrong, but our intuition that 1 + 1 = 2 is totally fine. It's a package deal.
And that brings us to our third and final pillar, continuity. This is just the basic intuitive feeling that the world persists from one moment to the next. It doesn't just flicker in and out of existence. It's why we see a movie, not just a bunch of random, disconnected still frames. Without this intuitive bridge, looking at data points on a chart and calling it a trend makes no sense. You're just connecting random dots. And that's not logic, it's an act of faith.
Okay, so we have our three pillars: space and time, small numbers, and continuity. This is where things get really, really interesting, because we're about to run into what our source material calls logic's self-destructive habit. It's this bizarre tendency for super advanced theories to use the tools of intuition to then turn around and attack intuition itself.
And this quote just nails the problem perfectly. It's like, imagine an artist using their brushes and paint to create an absolute masterpiece that proves the canvas they're painting on doesn't actually exist. The very act of creating the proof relies on the very thing being disproven. It's a fundamental logical contradiction. And you can see this dependency laid out perfectly right here. On one side, you have these big, abstract, theoretical redefinitions, like infinity, and on the other are everyday intuitive reality. But look closer at how those fancy theories are built. They are completely and totally dependent on our basic intuitive grasp of small numbers. You're using the thing you claim is an illusion to build the very tool you're using to disprove it.
And this really leads to an inescapable conclusion. If the foundational building blocks, that mathematical DNA like our understanding of 1 and 2, are just dismissed as hallucinations, then what does that make the complex theory you built from them? It's not a theory anymore. By definition, it's just a more elaborate delusion.
So let's talk about the big one, the concept that so often throws a wrench into everything: infinity. This is the ultimate non-intuitive disruptor, and this is where the whole argument comes to a head. This is the checkmate.
Just look at the mismatch here. It's almost absurd when you lay it out. In one corner, you've got our perceived reality,
We can see space, we can touch objects, it's right there in front of us. In the other corner, we have the concept of infinity, something we can define mathematically, sure, but something no human is ever or will ever directly perceive. So we're using a tool we can't see to disprove the world we can see. That seems completely backward, doesn't it?
To fix this, the framework proposes a really simple, elegant rule. A rule for logical fair play, if you will. It's called skeptical parity. And the idea is just this. You have to be at least as skeptical of the abstract, non-intuitive tool, like infinity, as you are of the concrete, intuitive reality it's trying to question. In fact, you should probably be more skeptical of it. And boom, there it is, the checkmate. If a theory, using all this fancy non-intuitive math, tells you that space is an illusion, okay, fine. But skeptical parity forces a critical question. How can you prove that the math itself, like 1 + 1 = 2, isn't also an illusion? I mean, your perception of space and your perception of numbers both come from the same cognitive machinery. If that machinery is broken enough to hallucinate the entire universe, why on earth would you trust the numbers it's spitting out? The theory eats itself.
So how do we avoid falling into this logical trap? Well, the source material proposes a clear protocol, a new rulebook for making sure our theories stay logically sound and actually grounded in, well, reality.
So here's the protocol. It's a 3-step process. First, you have to validate your foundational units. Treat our intuitive grasp of small numbers as the axioms they are. Second, apply skeptical parity. Always demand more proof from abstract concepts than from direct perception. And finally, you have to be willing to reject any theory that ends up in a logical absurdity, where the conclusion literally invalidates the premise it was built on.
When you boil it all down, here's the bottom line. A good theory is like a healthy tree. The complex branches, that's all the abstract thinking, they're only valid as long as they're connected to the strong, intuitive roots from which they grew. The moment a theory severs itself from those roots, it becomes internally inconsistent. It's logically dead.
And that leaves us with one final, provocative thought to chew on. In our quest to understand reality, maybe the biggest mistake is to build a proof that requires us to deny the very mind doing the proving. So you have to ask yourself, is it more logical to trust a formula we can't perceive or the world we live in every single day?